the subject operations research. And the today's topic of discussion is linear programming problem. In the previous class, we have discussed how the linear programming problem is formulated. All of us know how to formulate a linear programming problem. And the objective of today's discussion is how to solve graphically linear programming problem in order to find out the value of certain variables, keeping in view the objective of our business. So in several times, when we are running our business, we have to take some business decisions in respect to maximizations of profit or maximizations of revenue and the like. On the contrary, sometimes the business has to take decision in order to minimize certain things, like as cost minimization is the utmost objective of a business. So the nature of linear programming problem basically is of two types. One is maximization problem, and other one is minimization problem. So when we formulate a linear programming problem, then the second step is how to solve this problem. So we have two options. One is graphical solution of linear programming problem. And where the graphical solution is not possible, in that case, we will take the help of simplex table or simplex method. So there are two ways. Either we have to solve the problem graphically or with the help of simplex method. So always, in every situation, graphical solution is not possible. So when can we consider the graphical solution? In a particular situation where we are dealing with maximum two variables, keep in your mind, we are dealing with maximum two variables. In that case, we can solve the problem graphically. But when we are dealing with more than two variables, in that case, graphical solution is not possible. In that situation, we will take the help of simplex method. So today we'll learn the graphical solution of linear programming problem. In today's class, we will discuss how to solve maximization problem graphically. So go to your operation research note 1, so that at first we will go through the problem, right? One second, just I'm sharing this. Yes? Is it visible?
Yes, sir.
Is it visible to all of you?
Yes, sir.
Yes, sir.
Yes.
Visible.
Yes. Okay. Okay. So example 1. A manufacturer produces two products, P and Q. We have given name of these two products. One is product P, another is product Q. So we know that in order to produce any kind of product, we require some resources. Without resources, we cannot produce anything. So we are considering that in our business, we are going to produce two kinds of product. One is product P and another is product Q. And all product require some resources. So in this particular problem, we are considering two types of resources. One is machine hours and the other one is human resource. That means labor hours. In this problem, we are considering two resources. One is machine, another one is labor. So for producing product P, if we produce product P, a particular machine has to be worked for 2 minutes. And in addition, a worker has to work for 1 minute. So if we want to produce 1 unit of product P, then you require 2 minutes in machine and 1 minute will be required for labor. On the contrary, for producing product Q, another product, a particular machine has to be worked for 1 minute. So if you want to produce 1 unit of Q product, then you require 1 minute in your machine. And in addition, a worker has to work for 1 minute and 1 minute labor time is required. So obviously it is clear to you, we are considering two products and we are also considering two resources. So obviously we can solve this problem graphically because we are considering only two variables in this particular problem. Here two variables means two resources. One is machine and other one is labor, right? If the production varies, then obviously the machine timing will also vary. If the production varies, then labor hour, it will also vary. Therefore, we are saying that in this particular linear programming problem, machine hour is one variable and labor timing is another variable. So we are now going to this problem. In 1 hour, the factory can utilize 5 minutes of machine time. So in our hand, the machine hour per hour, it is constraint. It is our obstacle. We can maximize, utilize 5 minutes in a machine per hour. So we know that resource is limited. Resource is not unlimited. So in this particular problem, our machine timing is fixed. The maximum machine time that you can allot per hour in order to produce either product P or in product Q or both the products. Your timing is 5 minutes per hour. On the other hand, the labor timing is also fixed. Per hour, you can utilize the labor, that is 4 minutes, right? That is 4 minutes. Here it is clearly mentioned. In 1 hour, the factory can utilize 5 minutes of machine time and 4 minutes of worker time for those two products. The profit of each product is 5 and each product is ₹4. So if you produce product P, then per unit of product P, you can earn profit of ₹5. And in case of product Q, the profit is ₹4. This is our problem. So here the question is, graphically find out the number of each product which should be produced to gain the maximum profit per hour. So the objective of our business is to maximize our profit per hour and formulate the linear programming problem. So from this problem, first of all, we have to formulate this problem mathematically. And after that, we will think how to solve this problem. So formulation of problem, you already know. So again, I am repeating this. Formulate of objective functions with constraint equation. We are assuming that we want to maximize Z. Z is our profit. So we have written maximize Z. And we do not know how much quantity of P and how much quantity of Q will be produced in order to maximize the profit Z. That's why we are assuming that we will produce X1 quantity of P and we will produce X2 quantity of Q, right? So per 1 unit of X1, so per unit of P, you are gaining profit of ₹5. So if we produce X1 quantity of P, then the total profit from your first product P will be equal to 5x1 because you are producing X1 quantity of P. So for 1 quantity of P, your profit is 5. So for X1 quantity of P, your profit will be 5x1. In the same way, from the product Q, your profit will be, here it will be 4, right? 4x2, it will be 4, not 3. It will be 4 because the profit of each product P is 5 and each product of Q is 4. Therefore, just you will change this value, right? It is wrong value. Instead of 3, we will write 4x2. So maximize Z equal to 5x1 plus 4x2. This is our objective function. Now, after writing this objective function, then we have to write the constraint. We have to write the constraint. You have to write the constraint. So here the first constraint is for machine. So for 1 unit of product P, you require 2 minutes. So for X1 quantity of P product, you require 2x1 machine timing, as well as for product Q, you require 1 minute, right? You require 1 minute. So therefore, it is coming 2x1 plus x2. It might be equal to 5 or less than 5, because our maximum capacity is 5. So in case of the maximization problem, the nature of the constant, it will be less than equal to, right? So here this is one constant, 2x1 plus x2 less than equal to 5. And similarly, we have established another constraint, because our total timing of labor is 4, right? Therefore, we can establish the second constant, x1 plus x2 less than equal to 4. And the third is non-negativity condition. We have already stated you earlier. In case of the linear programming problem, non-negativity condition is to be fulfilled. Therefore, we have written x1 comma x2, it should be positive, greater than equal to 0. Is it clear? Is it clear to you?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Up to this,
Yes,
it is
sir.
clear?
Yes,
Okay,
sir.
okay, no problem, no problem.
Yes.
Yeah. Now we are coming to the solution part of this linear programming problem. So for the solution part, at first, we should consider the constant. The first constant is 2x1 plus x2 less than equal to 5. This is now in inequality form, less than equal to. So for solving the linear programming under graphical method, the inequality should be converted into equality. So if we make it equal, then we can write 2x1 plus x2 equal to 5. We are not considering the inequality sign. If we consider the inequality sign, then we cannot solve the linear programming under graphical method. In case of the second constant, what we are writing, x1 plus x2 equal to 4. So what we have done? We have done only the two constants which were in inequality form. We have converted, we have transferred these constants into equality form. Now, find out two coordinate points for each equation. So from each equation, we have to form a straight line. From each equation, we have to form a straight line. And if you want to make a straight line, then at least you require 2 points. Otherwise, you cannot make a straight line. So we require 2 points, that is 2 coordinates. And if you know the 2 coordinates, then you can easily draw a straight line on the basis of 2 points, or we can say it 2 coordinates. So here what we have written, just we are dividing 5 both sides. We are dividing 5 both sides. So 5 by 5 equal to 1, and here it will be x1, 2x1 by 5. That means x1 by 2.5, right? 2x1 by 5. What it implies? x1 by 2.5, right? And here we have written x2 by 5. Now, from this, we can easily find out what would be the 2 coordinate points. Here the coordinate points of this equation, in this first case, x1 value is 2.5. Therefore, x2 will be 0. x1 value is 2.5, and here there is no value of x2. Therefore, we are assuming x2 equal to 0, which is x1 intercept. And in the same way, here the value of x2, right, equal to 5. Therefore, the value of x1 will be 0. So we are getting 2 points. One is 2.50, another one is 0.5. So with the help of these 2 coordinates, 2 points, we can draw a graph. We can draw a straight line. Just I am coming to this straight line, right? So what points you have got? 2.50, right? So here we have written 1, 2, 3, 4, 5. And here we have, along the y-axis, we have also written 1, 2, 3, 4, 5. So first point is 2.50. So 1, 2, this is 3. So obviously this is 2.5. So this is 1 point. And another point is 0.5. So this is the 0. Now we'll move along the y-axis. 2, 3, 4, 5. So if we get 2 coordinates, then you can easily draw a straight line. Now here we have drawn this straight line, right? And this is C, and suppose this is M. You can write here M also. So we have got one straight line, that is MC, MC, right? Now we are coming to the second constant. In case of second constant, x1 plus x2 equal to 4. So similarly, we can divide both sides by 4. Therefore, we can write x1 by 4 plus x2 by 4 equal to 4 by 4 equal to 1. Again, we are getting 2 points, 2 coordinates. And what are those 2 coordinates? Now, obviously, from here, we can understand the value of x1 is 4, and here there is no value of x2. Therefore, the coordinate points is x1 equal to 4 and x2 equal to 0. In the same way, here x2 is 4. Therefore, obviously, x1 value will be 0. So here we have written x1 is 0. First one is x1. Then we will write the value of x2 in order to get the coordinates. So 0 and 4. So again we have got 2 points, 4, 0 and 0, 4. So with the help of these 2 coordinates, we can also draw another straight line. Just go to the graph. We have drawn another straight line, 4, 0. This is 4. This is the 4, 0 point. x1 is 4. x2 is 0, another is x1 is 0, and x2 is 4. x2 is 4. So we may draw another straight line in this way, another straight line, right? And we can also give name. Here it is written A, and here you can written Q. So we are getting another straight line, A and Q, A and Q. And previously we have got a straight line MC, MC. So we have got two straight lines. One is MC, another is AQ. Right. Now, these two straight lines intersects at this point B. So how this B value can be found out? Simple task. If we solve these two equations simultaneously, that means 2x1 plus x2 equal to 5 and x1 plus x2 equal to 4. So just to solve these two equations, and if you solve these two equations, then you will get the value, 1, 3. x1 equal to 1 and x2 equal to 3. This is your B point. Right. This is your B point. Now, we'll consider all these corner points. So what are the corner points are there? We have got corner points 0. This is one corner point. Here this is one corner point along the x-axis. Along the x-axis there are two corner points. One is C, another is Q. But in case of maximization problem, we should consider only the inner corner points, right? Only we should consider the inner corner points. So although there are 2 points, one is C, another is Q, but we consider the inner one from the 0, 0 origin. So inner one is C. So we should consider, right? In the same way, if you go to the y-axis, again there are 2 points. One is A, another one is M. Which one is corner? From the 0, 0 origin, obviously A is the corner point. So along the y-axis, A is the corner point, and along the x-axis, C is the corner point. Now, we are also taking the consideration of this intersection point. Otherwise, we cannot get the enclosed area. So, what is the feasible area in this case? Now, D, A, B, C, D. So, this area is the feasible region. Graphically, we can say that this area will be called as the feasible region or the viable region, where we can think about the utilization of our resources within this limit. Will not go to the side or will not go to the upper side, right? So the feasible region is, here we have written A, B, C, D, A. A, B, C, D, A. So this area is the feasible region. Now the second step is that now we should consider all the corner points and will put all the value of the coordinates of these corner points into our objective function. So what is our objective function? Now our objective function, here it will be 5x1 plus 4x2, 5x1 plus 4x2. Now we can put all the coordinates, all the corner points, and we'll get the value of z. And after that, we will compare where the z value is the maximum. So now coming to this point, we are considering 4 corner points. We are considering 4 corner points. Here we have written value of the objective function. So obviously it will be 5x1 plus 4x2. And suppose it is 3x2. So what points we are considering? A corner point, and here the value is 0, 4. B corner points, intersection point 1, 3. C corner points 2.50, and D is the origin 0, 0. So if we put the value of x1 and x2, in the first case we are getting 12, in the second case we are getting 14, in the third case we are getting 12.5, in the fourth case we are getting 0. So where is the value has become maximum? In case of 1 and 3, the profit is maximum. Therefore, we can say that we will produce x1 quantity of one quantity of product P and 3 units of product Q, so that our profit will be maximum. So again I am repeating this. This is our solution. From this table we will get the ultimate solution after considering all the corner points, the coordinates of all the corner points, and then we'll get the value of z, and where the value of z is the maximum, that coordinates will be taken into consider. So here we can say that we will produce 1 unit of product P and we will produce 3 units of product Q, so that the objective of our business, that is the maximization of profit, it is possible. So in this way we can solve linear programming problem, maximizations problem graphically. So in the next class we will consider the minimization problem graphically. And before going to discuss the minimization problem in our second class, you will just go through this problem. You will just go through this problem. How this problem is different from the first one. How it is called minimization. This is not the maximization problem, because in the last line we have written that to have least cost by the help of graphical method. From here you are sure that this problem is relating to the minimization problem. So we will go through this problem, and after that you will formulate this problem, and then after that you will find out all the coordinates then you will draw this graph, right? This is your home task. Up to this, you will complete. And in the next class, then we'll show you how we can get this result, right? So in the next class, that is, I will take class on Thursday, whatever the time has been mentioned in our online routine. So in the next class, we will cover the minimizations problem, and after that, we will learn how to solve linear programming problem with the help of simplex method. So thank you for your patient sharing.
Thank you, sir.
Thank you
Thank
all.
you, sir.
Stay home.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir.